This is the lesson for 5-2 algebra. I can write and graph exponential functions and describe the attributes. This is a 2-day lesson. This is the day 1 video. So exponential functions are written in the form f of x equals a times, in parentheses, 1. Now this symbol you might have not seen before. This symbol is plus or minus. All right, sometimes it's plus if it is growth or increasing. It is minus if it is decay or decreasing. So you're not going to have a plus minus symbol. You're either going to have plus if it's increasing, minus if it's decreasing. And then the R stands for your rate, and then to the x power. Or sometimes they write it as f of x equals a times b to the x. So what do those things in those formulas mean? A is the number that you start with. It's sort of like the a sub 1 from the previous chapter. It's the term that you start with. So if you were starting off with a population of 10,000, that a would be 10,000. When we go to graph it, it is the y-intercept. B represents the growth or decay factor. It's the number that you multiply. Now, the way that we find this is we have to do 1 plus or minus the rate. Now, the R is the rate. Rate is a percent. We want to change it to a decimal in order to put it into the formula. The way that you make a percent into a decimal, if you had, for example, 25%, to make that into a decimal, you have to move the decimal point over 2 places. So this becomes the decimal 0.25. If we had the decimal as 1%, we would have to move the decimal point over 2 places to the left still. So our new decimal point is here. We have a 0 as the placeholder. So this becomes the decimal 0.01. If we had the percent of 1.5%, we have to move the decimal point over 2 places to the left to make it into a decimal. So this becomes the decimal 0.015. And again, you are going to add it to your R. You're going to add it to your 1 if it's growth, meaning the numbers are increasing. You are going to subtract it from 1 if it is decay or decreasing. Growth means increasing, decay means decreasing. The growth and decay factor is your B, that's what you multiply by. Your growth or decay rate is R as a rate as a percent of increase or decrease. So I know that sounds a little bit confusing, but it'll make sense when we start actually using these numbers. So some examples in real life. Whenever you hear on the news or read in a news article that something went up by some kind of percentage, like the percentage of population of a city. Maybe they were having a big boom in business, and so a lot of people moved to the area. Maybe you had a 5% increase in the percent of the population of a city. Or the stock market. Every day on the news, they say whether the stock market went up or went down, and they normally use it as a percent. Or it had a 2% increase or a 1.5% decrease. So those are some examples of real life. So let's take a look at some actual problems. At this moment, the population of downtown is 20,000 and the population of uptown is 6,000. So we have 2 separate problems here. But over the years, people have been moving away from downtown at a rate of 1.5% every year. At the same time, uptown's population has been growing at a rate of 1.8% each year. So downtown is, if they're moving away means that it's going down. So it's a negative percent because it's going down, it's decay. So 20,000 is our A term because that's what the population is that we are starting off with. So the 20,000 is our A. Our rate is 1.5%, but remember, we don't want it as a percent. We want it as a decimal. So we need to move this decimal point over 2 places. So our R is really 0.015. And since they're moving away, this is very important, since they're moving away, it would be a negative. This is 0.015. So when we go to write your f of x, we have, remember the formula is your a value, your starting off value, times, in parentheses. Now it's really 1 minus 0.015. It's minus because the population is going down. So we're going to subtract that. And then that's to the t power. The t is how many years we're talking about. So if we simplify this, we could simplify these two things together. We could subtract them to make our formula a little bit easier. And you will have to do this. So 1 minus 0.015 is 0.985. That's a little bit simpler of a formula. So that is our f of x. And again, we subtracted because the population was going down. In the population of the next one, the population is going up, so we're going to add. But let's get back and finish this one. What will the population be in 5 years? All that you need to do is take this 5 and sub it in for t. So we have 20,000 times 0.985 to the 5th power. So if I go over here to the calculator, 20,000 times 0.985, close my parentheses, to the x power. All right, remember you don't have a t on your calculator. Hit enter. Oh, but we don't want x, we want 5 because we want 5 years. So hit enter. Now, you can't have a partial person. All right, we want whole people. All right, so you're just going to round to the nearest whole number. So in 5 years, the population would be 18,544 because you're rounding to the nearest person. In 10 years, what would it be? Well, we would have to take 20,000. And again, it's that 0.985. But this time we're doing it to the 10th power. So again, we have 20,000 parentheses 0.985, close my parentheses, to the 10th power. And now after 10 years, the population, because remember the population keeps on going down, it is 17,190, that would round to 95. So it went down to 17,195. For Uptown, we're starting off with 6,000. So that's our A value in our formula. The percentage is 1.8, and it's going up because it says that it's growing at a rate of 1.8%. We still need to move our decimal point to the left to make this into a decimal. So 0.018, that's our R. So f of x equals 6,000 times, now this would be 1 plus 0.18 to the t power. It's plus because it's growing. In the previous problem, we did minus because it was decay. It was going down. This is growth. It's growing, so it has to get higher, so we have to add it to the 1. So when we go to type it into the calculator, the easier form is 6,000 times 1.018 to the t power. What will it be after 3 years? So you're going to take and sub in a 3. So we're going to have 6,000 parentheses 1.018, close my parentheses, caret button, and we're doing to the 3rd power. So our population is going up. It would be 6,330 when we round to the nearest person. After 12 years, we would have 6,000 times 1.018 to the 12th power. Hit enter, and you get 7,432. So our population was going down. It started off at 20,000 and went down. It started off at 6,000 and went up. Anytime it goes down, you have to use that minus sign. Anytime it goes up, you have to use the plus sign. So at this moment, the population of downtown is 20,000 and uptown is 6,000. But over many years, people have been moving away. It's the same thing. Downtown is going down at a rate of 1.5%. Uptown is growing at a rate of 1.8%. So you can see our formulas, right, for downtown and uptown. Now, this is a totally different kind of problem. When will the population of uptown be 8,000? So uptown is starting off at 6,000. We want to know when it's going to be 8,000. Now, the way that you're going to do this is in your y equals, you are going to type in our formula for uptown. All right, this is dealing with uptown. So we're going to type in 6,000. This is sort of like that f of 5 or f of x. You got to make sure that you're subbing it into the right place. We want to know the final answer this time. Last time we were given the years and you had to find the population. Now we're being given the population and you have to find the years. So we have to sub it into the other spot. So what we're going to do is we're going to type in this formula. And when we go to type this into your y equals, remember that you have to use x instead of t. So now what we're going to do is we're going to use our table to find our answer. So when you look at your table, we want the population. When will it be 8,000? Well, when I look after 10 years, it's 7,000. So I need to keep on going down on my table until we reach 8,000. So 8,000, if you look at the bottom of the table right now, 8,000 is somewhere in between 16 and 17 years. So it is in between 16 and 17 years. Do we know exactly when it will be? No, we don't. But we know that it will be sometime in between 16 and 17 years. And that's how you're going to leave your answers for these. So let's skip down to this third one because it's the same problem. When will the population of uptown double? All right, double. Well, it started off at 6,000, so we want to know when it's going to be 12,000. So if I keep on going down on my table until I get to 12,000. Sometimes you're going to have to go down pretty far. So there I hit 12,000. So it's somewhere in between 38 and 39 years. Again, how I got this was I typed my original equation into my y equals and I hit seconds and table. So now I'm going to go back. All right, now I'm going to go back for my second y equals. All right, I'm going to actually go down to y2. I'll show you why in a second. So for downtown, I have 20,000. Parentheses, 1 minus 0.015. And you could have subtracted those before you typed it in, all right, to the x power. So now I'm going to do second and table on this one. Now remember, I'm in my y2 column now. So I want to know when it's going to be, for downtown, it's going to be 15,000. So I actually have to go back up on my table a little bit because I want to know when it's going to be 15,000. So 15,000, I went too far. So 15,000 hit right in between here. All right, you see 15,008, 14,783. So in between 19 and 20 years. When will it be half of what it was? So we're talking downtown, right? Downtown started off as 20,000. So we want to know when it will be 10,000. So I need to keep on going down. So there I just hit 10,000. It's in between 45 and 46 years. The last question is why I did them both in Y1 and Y2 at the same time. When will their population be equal? All right, so we need to see when these numbers are going to be the same in the blue column and the white column. So if I take a look, and I think I just went too far. If I take a look, so when are they going to be equal? So we have 11,000, 11,200. Over here, we're getting into 11,000s. We keep on going down. In between year 36 and 37, notice that that like 11,500-ish year is going to be in between 36 and 37 for both. So that's when they're going to sort of cross and be equal. So in between year 36 and 37. That's when it's going to be equal. You just have to compare the two columns. So in the next one, it says the population of wolves was at 500. In an effort to keep them off the endangered species list, new regulations were made to protect habitat and food sources. Population was found to raise by 12% each year. Write a function for this situation. So we're going to say the f of x equals, remember the first number is what you start with. We're starting with 500 times in parentheses. Now, because it's going up by 12%, 12%, if I move my decimal point over 2 places, it's really 0.12. So because it's going up, we're going to use a plus sign. So 1 plus 0.12 to the x power or to the t power, either way. So that's our function. And we could add this together to be really 1.12 right there. What will the population be in 10 years? So I'm going to hit second and quit to get out of that. I'm going to do 500 parentheses 1.12 parentheses caret button, and it is 10 years. So I'm going to stick my 10 into here in my formula. So to the 10th power. Hit enter, and rounding to the nearest wolf. So this would be 1,553 wolves. Actually, in this one, it does happen to be 1,552, right? Just because of how the how it will be written. After 10 years, it gets to be that, but did it get to that next wolf yet? No. All right. So in this case, you wouldn't round. And it all depends on how the question is worded. This one would be 1,552. It gets to be that, but they didn't get to that 53rd wolf yet after 10 years. So because things are being born, that's how you wouldn't round this one. All right. Sometimes you round, sometimes you don't. Depends on how the question is worded. Let's take a look at this one. A sample of bacteria is growing in a petri dish. The number of cells doubles each day. Now, if something is doubling, it is a 100% increase. If it's doubling, it is a 100% increase. So making 100% into a decimal, 1, 2 places, that's really the number 1 as your rate, all right, 100% increase. There are 25 to start off with. So A is 25. Our B, remember our B is really B equals 1 plus the rate. This is our rate, all right, as a decimal. So 1 plus 1. So this B is really a 2 here because we really have f of x equals 25 parentheses 1 plus 1. I'm getting this 1 from the 100% to the x power. So that's why our B is really a 2, because it's really A times B once you add them together. inside the parentheses, it's 1 plus r, but then that 1 plus r equals your b. So how many would there be after 4 days? So 25 times 2 to the 4th power. So we get that there is 400 after 4 days. After a week, now remember a week is 7 days. So we're going to do that same thing, but with 7 this time. 25 times 2 to the 7th power. So we get that there's 3,200. When will there be 10 times as many? Now 10 times as many. 25 times 10 is 250. So I want to know when there's going to be 250. So I need to go to my y equals. I'm going to clear out my equations from before. And I need to type in our original problem here, 25 times 2, really 1 plus 1, to the x power. It's second in table. And now I want to know when it's going to be 250. Now I need to go way back, right? I need to go way back here. Remember that E means times 10 in scientific notation, but if I go back farther, I can see that I'm going to have some better numbers here that I'm looking at. I'm looking for 250. All right, when is it going to get to 250? Somewhere in between day 3 and 4. That's when it's going to reach 250 because 3 is 200, 4 is 400. So it's going to reach that 250 somewhere in between day 3 and 4. And our last one, a new antibiotic is developed. It kills 1/3 of the cells every day. The sample had 24,000. So this is our A. That's what it's starting off with. Now you have to be careful in this one. All right, where you have to be careful in this one is that it kills 1/3. So that means it's going down by 1/3 every time. Well, what is 1/3? 1/3 is really 33.3 repeating percent. Well, if it's going down by that, 1 minus 33%, all right, 1 minus 33.3%, or 1/3, all right, is going to be 2/3, or 66.666666 repeating percent. So that's really the amount that we have left. So this is really either you could use 2/3 or 0.66666666 repeating. So our function is going to be the f of x, because that's how much is left. All right, it's getting rid of 1/3 each time. So 1 minus that 1/3. So we have 24,000, which is what we start off with, times. Now you could just use the fraction 2/3 if you wanted to use, because that was really 1 minus 1/3 of it. So that's where I'm getting the 2/3 from. Or again, you could use the decimals and use 0.6 repeating. Once you move the decimal point over 2 places, this becomes 0.6666666666. All right, repeating. So to the x power. So how many cells will be left after 4 days? So I need to go back to my calculations here and do 24,000 times. Now I could do 1 minus 1/3, or 1 minus 0.333333, or I could do just 0.666666, or remember, you could always do a fraction as well. Alpha y equals 2 divided by 3 for 2/3. All right, I could do it like that as well. All right, or again, 0.666666 would be fine too. And we want it to the 4th power. So we get that number. Now, that's not really a number that we really want if you use a fraction. That's why I like using decimals better. But so I need to actually figure out what that is. 128,000 divided by 27. So that's really the number 4,740. How many will it be after a week? A week is 7 days. So I'm going to do that same thing. Let me show you what it would do if you typed in, use 0.666666666. Make sure if you use a repeating decimal, you type in enough sixes, all right, like 7 or 8 or 9 or 10 of them. This is to the 7th power. So that gives me a better number. That gives me 1,404. Again, I could have done 24,000 times 1 minus a third, or this 0.3333 because it went down by a third. All right, I could have done this as well. It will end up with the same answer. I just want to show you that. It ends up with the same exact answer. All right. When will the sample be back down to the original number? All right, so when will it be back down to the original number? So we need to go to our y equals. We need to type in our f of x, so 24,000. Parentheses, 2/3 or 0.6666666. That's what I'm going to use. To the x power. Second in table. And now we are looking, all right, we're looking for 25. So that's where it is. All right, we're looking for 25. So 25, remember, where am I getting that 25 from? I'm getting that 25 because there are 25 to start with. This is the same question, right? That's where I'm getting that 25. So when will it be back down to the original number that I started with, 25? If I go to my y equals and I go down in between 16 and 17 days. So again, you have to make sure that you are subbing things into the right place. All right, remember that it is growth. If it's growth, you're going to add it. If it is decay, you're going to subtract it. All right, make sure that you change your percent to a decimal by moving it over 2 places to the left. But this is the formula that you're going to use. Your A is your original number, times in parentheses 1 plus your rate or 1 minus your rate, depending on if it's growth or decay. And then that's to the x power. All right, but make sure, the biggest mistake that people make is not changing their percent into a decimal. You always have to change your percent into a decimal. Growth is adding, decay is subtracting.